hope all of you are doing great. And I'm live yet again. The next question that we are going to solve now is, okay, I hope I am visible. And it's a nice question. Okay. Okay. I'm not going to write it because I've already solved it in the past. Just run a while loop and keep reversing K. I've done this already. I will not write the code for this. I mean, this is complete time waste. So you make a dummy node, previous hand group and all of that. And for K, you just keep on moving. You keep moving across n nodes. Yes, this is fine. Will not do it. Okay, I will do this question now. Also, how to find the start of a cycle? You have to start off a cycle. Hi ChatGPT, I want to confirm one thing, that in a linked list cycle you can easily find it with slow and fast pointer, which is DSA algorithm. But if you want to find out the head of the cycle, then we have to move the slow pointer to 0 again and keep the fast pointer there only, and move the slow and fast pointer by one step each. Is that the algorithm? Yes, that's exactly the flow cycle detection algorithm. Detect whether a cycle exists. Use two pointers, slow and fast. Slow moves once. Find the starting node of a cycle. One slow and fast move. Move one pointer usually slow back to the head of the linked list. Keep the point at the meeting position. Move one pointer one step at a time. The node where they meet again is the that. Yep. Yeah, you're right. Fine, guys. Now we are going to do this question. Given the head of a linked list, remove the nth node from the end of the linked list. Nth node from end is n minus k node from start. And just remove it. Find the size and then just remove it. Let me see how I've done previously. Yeah, you find the length, iterate overall. The start node is this. Get the start next you move to. Yeah, this is fine. Easy. Rotate list. This is fine. Oh God, I've done many more questions. Yeah, sorry guys. And the next question is rotate the linked list. Also, I missed one question. Remove duplicate from sorted list to. I will solve it just after this. Give us the head of it. Rotate the list by key places. Oh, this is easy. So we have 1, 2, 3, 4, and 5. Rotate by k. So what to do? You reverse it completely. So it is become 5, 4, 3, 2, 1. Yeah. For rotating, we reverse it. After reversing, we just take this part. Then just reverse this. Then just reverse. Two reversals. How I solved it in the past. Wait. Hi ChatGPT, for rotating a list to the right by k places. One is the normal approach, which is this approach optimal, that we first reverse a complete list, then reverse the first k and the rest of the list. So this is like three reversals and we'll get the answer. Is that the optimal approach? Yes. Break the circle. Make it a circular linked list. Go to k, n minus k minus 1, and break the circle. Yeah, this is also possible approach. Partition list. I will solve LRU cache because that is very important. Oh, is my name not working? What the hell? Hmm. What is wrong? What is wrong, guys? Interesting. Given the head of a linked list and the value x, partition it such that all the nodes less than s comes before the nodes greater than or equal to x. Keep 2 and attach. This is easy. Very easy question. Keep two heads and attach. Yeah, partition 1, partition 2, keep attaching. And then attach the one. This is easy. I'm not going to do it. Remove duplicates from sorted list to what? Remove duplicates from sorted array, sorted list. A different version. Okay. This is the question. Delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Okay. So you have 1, 2, 3, 3, 4, 4, 5. Given the head of a sorted linked list, delete all the nodes that have duplicate numbers, leaving only distinct numbers from the original list. Okay. This is fine. We keep a previous number, we keep a previous node. The number is not equal to, then move. This is easy question. I'm not going to solve it. Keep a previous, keep a previous. Yeah. Keep a dummy head, keep a tail. Duplicate. While the number is same, keep on. If it is not duplicate, then move. Yeah. You don't even have to do this, because if all are duplicates, then what? If all are duplicates, then what do we do? We didn't even need that change. Yeah. What if all are duplicates at the end? Hmm. This was easy. This is a nice question. I will solve it. Complete. I will solve this. This is a nice DQ implementation. Just 2 minutes. No, it hasn't been 2 minutes. So, guys, we are going to solve this question. This is a very, 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 very popular question. It is one of the most popular questions of the industry. of job market. This initializes with positive size, which is capacity. Returns the value of the key if the key exists. Put key value. Update the value of the key if the key exists. Otherwise, add key value pair to the gap. If the number of keys exceeds the capacity, evict the least recent used. कैश तो इनिशियलाइज कर लिया. ठीक है. डिलीट तो नहीं कर रहे हैं ना. हाँ ठीक है. ठीक है. फाइन फाइन. ठीक है. डी क्यू यूज करेंगे ऑब्वियसली, क्योंकि पीछे से भी निकालना है और आगे से भी निकालना है. डी क्यू सपोर्ट्स इरेज इन ऑफ वन. Does DQ support erase in O of 1? Wait. In O of n, I think. It supports it on in O of n. Yeah. Length and right? Left and right? What? What do you mean by left and right? How? Oh, okay. Wait. What we will do? We will keep the pointer. We'll just move it to the front. How do we move it to the front? We'll push it to the front, but to push it to the front, you also have it to this. We need a hash map. Where we store all the vector pointers or DQ pointers, let's say. Iterator pointers. We have the iterator pointers. Can it be deleted? If I have the DQ iterator pointer, can it be deleted? No. We can use a double-ended list and not a DQ. Because that is O1. Sorry, why am I thinking about DQ? Wait. DQ is double-ended Q. And list is by default a double-ended list, right? Yes, DQ stands for double-ended queue. It supports push back, pop back, push front, pop front. List is a doubly linked list, not a double-ended queue. What? Doubly linked list. Double-ended list nahi hai, doubly linked list. Sorry, bhul gayi purana. It has all of this. If we want, does list support erase, and in that we pass the value. If we pass the value, shouldn't it be of n? How is erase of 1 in list? Erase by iterator and erase by value. We have two options of erasing a list. Erase by operator is of 1. But hi, I have one doubt. So whenever we want to erase with an even with an iterator, that iterator points to the element we want to delete or the node in the linked list which we want to delete. In order to do it in of1, we should have the previous pointer, the previous, and next we will find out with next. But is it a double linked list? So previous and next are already present, and then we'll be able to find with it in of1. Yes, exactly. In a double linked list, there is previous and next. Can you tell me what all are the STL functions in a list? Because and does list work on index or it works on iterator? I forgot because I think it is not continuous, so it should not work on index. I forgot. Can you tell me all the operations of a list STL? You are correct. STD list is a doubly linked list, so elements are not stored contiguously. List is this: LST 0 and 1 are not allowed. No indexing support. Everything is done using iterators. So we can push front, we can push back, we can insert before an iterator, we can delete, we can erase, we can remove some elements, we can do front back, we can do size, we can do empty. The only difference between list and DQ, because both of them support push front, pop, push back, pop front, pop back, remove, erase, size. The only difference is that in a list we can delete in of1 with erase using an iterator. Is that right? Not quite. So push front, pop, push back, pop front, pop back, random access, begin plus k, erase, insert, memory, cache, sorting. Of1 and both, push back, of1 and both, push front, of1 and both, push back, of1. Random access, of1, but list is not supported. DQ supported? What the hell? Begin plus k. Not supported. I have one doubt. Why is random access supported in DQ? Is DQ contiguous? Like, can is it? But I don't remember in Q we don't have any index, right? In DQ do we have indexes like a list? Sorry, a vector. Q versus DQ. Q is an adapter. You can only do push, pop, front, back. You cannot do this. What about DQ is a full container just like a vector? You can do cout, DQ add, DQ20. So yes, it's supposed contiguous. No. DQ is not fully contiguous like vector, but it stores elements in contiguous blocks and maintains additional indexing, which allows O1 random access as well as O1 insertion. Fine. So we'll use a hash map. unordered map. Are all the values unique? No. Key. Put, get. Wait, what? Put has a key and value. Capacity, which is just 2. Put has a key and value. Key is 1. The value is 1. Next put has 2, comma 2. Then get is the least recently used, which is 1. Then get, put has 3, comma 3. Okay, unordered map. So there is an incapacity. This capacity, you fill from this capacity. Then there is an unordered map of int, comma, list. List. How do we make a list? Just make a list, right? In C++, we can just create a list, right? I think so. Yeah, we can just create a list. List star map. Okay. When we put an auto IT, which is, oh sorry, just do this thing. You also use a queue. You also use a list. List what? Int lst. lst. lst dot pushback key. Where push back the key in the list and auto IT, which is equal to lst dot back. This is the last sentence. Start and back, begin and end. Yeah, begin and end. Now, this iterator you put in the map. So in the map for key, you put this, which is IT, comma, value. And it is obviously going to just get out of scope and return. But there should be a get option here. In this get, what do we do? In the put, if it exceeds, then that's a problem. Sorry. If so there is the if lst dot size, this will give capacity or size. I think this is capacity. List dot size gives capacity or just how many elements currently inside. I think it just returns an currently present. Yeah, there is capacity because the linked list allocate nodes individually. Oh yeah, you're right. So the list dot size, if it is greater than equal to 2, then we have to evict. In order to evict, what we do? We get the key. So auto current is map of key, which is lst dot back. Okay, lst dot lst dot back pop back. And also don't forget to delete it from the key, from the map dot erase whatever this was, lst dot back, and then just push it. Oh, sorry, capacity. Just remove one, right? You just remove one and then continue. If not, then just continue. Forget it is important. Forget auto current is map of key. Do one thing, int value which is equal to current dot second. Return this value, but before that, also from the LSD, erase this one thing which is iterator, which is current dot first. In the LSD, push front what? LSD dot push front you erase, and in the LSD you push front. What do you push front in the LSD? Weirdly, let me think. Fine. And don't tell answer. Just tell what is syntax issue here. Oh yeah. Wait, there is some mistake. Oh shit. Oh yeah. Yeah. Oh shit. The key might be present. Hmm. Remove it. Nice design question. ठीक है, ठीक है जी. I'm going to do all the bit questions now. I'm starting with bit. 1 second, guys. Hi guys. Hi guys, I'm so sorry. Hi guys, sorry I was very busy. But now I'm going to start with bitwise. One second, I'm going to set my camera. I got few mails that I had to reply to. Now I'm fine. So we just saw and we completed. So we just didn't saw means in my life I just completed LRU cache, which is very important question. One second. Yeah. So LRU cache is done with hash map because we want to erase. And in a double-ended list, we have two options of erasing. One is with iterator, one is with value. But the complexity of value is O of n because we have to iterate the complete double linked list in order to figure out which node to delete. And then we use the previous and next to delete it because we have previous and next in a double linked list. But if we have an iterator of the node, we can delete it in O of 1, and both of them are supported because here it is asked to get the complexity of get and put in average of one complexity, and therefore we used and an ordered map to keep the iterator storage. We stored the iterator for the key. That's it. Moving on to the next question, which is add binary. So guys, I am now I've now started solving the next topic, which is bitwise manipulation. And guys, all these questions I've written here, which we are going to solve in this under this topic, which is bitwise. These are the 6 questions which we will be solving. These are the linked list questions that we just solved. These are the linked list questions that we just solved since morning, and now we are going to solve bit. We will not solve maths. We have already done DP. This question is really nice, triangle, but we have already done DP. We have done extra trees. These questions are good. Binary camera is very nice question. Record BST, nice question. Path, some nice question. In this, you have to return a value 0, 1, 2. So this is kind of state DP. We have done graph, we have done trees, we have done, so these are all the graph topics that we have done. We have done trees, we have done pattern, we have done array, we have done linked list, but there are some topics still left. 2-pointer, I will just mark 3 sum because we have done it. Container with most, what I've already done it with 2-pointer. Roman to integer, integer to Roman. I think this is fine. This is greedy. I will not do it. Although this is popular question, but I've done it. I think I did it in Python day before yesterday. So jump game, we have done gas station, done candy, done product, etc. So it's okay. I'm not marked most of these questions for now, but fine. Do some, I've done it. I will not do it again with hash map. You can also do it with 2-pointer, but that's fine. Hash map is better. Summary ranges, insert interval. Interval questions are important. Stack valid parentheses I've done. I'm not going to do it again. This is a very easy question. Minimum number of arrows to burst balloon. Partition DP we've done. Linked list we have done. Binary tree journal we have done. Binary tree PFS done. This question was nice. BT traitor because we do lazy propagation with a stack. Very nice question. So in this question we only put the right side into stack and then we just use that and populate the left. This is very nice question. The very nice question. Yes, very nice. Let me see this question again, just for revision. BT traders, BST traders. Sorry. Very nice question. We put it in stack. We populate the left whenever needed. Has next. Moves the pointer to the right. Oh, for doing in order traversal. Fine. As next, we have to check if the stack is empty because every left is going to have some right. But whenever we check next, which moves the pointer to the right, we check the node. We pop it. If it has a right, we populate all the left. I kind of forgot. I forgot doing here. Shit. I remember I did this question a week back, but wait. This is one of my favorite questions. We initialize an object, the root is given. Returns true if there exists a number in the traversal to the right. Just this, yeah. While putting basic data, we populate all the lefts. Keep populating all the left. Why do we keep populating the left? What? I forgot. Because we are given the in-order traversal. Implement this. We have all the left. Answer is always going to be the right one. Left, root right. This becomes the root. Move the right later. This is the constructor. We have the root. We have populated all the lefts. How do we populate left? We have the root which is 7. We keep pushing because this is a stack. So it is in opposite direction. So we have put 7, 3. 3 is the top. Now next, moves the pointer to the right, then returns a number of pointers. So we have this, next, next, has next. Sorry. Next, which is next is 3, then 7. हाँ ठीक है. Next is 3, then is 7. Yes, because it's in order. And then as next is obviously 9. But in the stack, when we'll populate left, 9 will be on the top. Nice, yes. Yes, I remember the concept now. But fine, it was very nice question. BST, graph, tree, course schedule. These are just algorithm. Binary search. This question was nice. Find peak element in a rotated sorted array. But I'm not going to do that. I will do. 8 guys. I've been very busy lately. So next, we are going to solve the next question, which is oh, okay. We are given string 1, 1. Given this 1. The sum is what? I don't know. 1 plus 1 is 0. And then 10. Oh, it's fine. Start from back. And take a and. Take a or. Oh, this question is easy. This is quite easy. See, we started from back. We took the sum. We added it minus 0. Result is sum. Let's do some right. Oh, this is easy. Oh. Okay, I will not solve this reverse bits. Reverse bits. I know there is only alternate. Is there a O? Oh, I have started this question. This question is really nice. Next one. Prithvi Raj Patel. Yes. Okay. Thank you for confirming. Give 1 second. I have to mail something. 1 second. Okay, guys, no problem. Okay, guys, now we can do it. Oh. Mhm. Where's the text? We do a lot of it. We can just do a lot of it. Oh no. अगर हमने इसका उल्टा कर दिया तो ये सारे 1 हो जाएंगे or not करने के लिए 0 1 should be 1 1 0 should be 1 1 1 should be 0 0 or 1 0 should be converted to 1 1 should be converted to 0 if we see XOR and do XOR of 0 XOR 1 the answer is 1 if we see 1 XOR 1 the answer is 0 if we okay we do a XOR convert all to 1 and do a XOR how do we convert it to XOR how do we convert it to all ones एक second guys so take a XOR with 1 I'm able to think of something this time. I'm close. I'm thinking something of this type that I create a mask which has all ones there and then take a XOR with all the bits of that. What do you think? Like I found out the size, then I've taken a mask of 2 raised to power n minus 1 because if 2 raised to power n everything after that is 0 but 2 raised to power n minus 1 everything after that will be 1 and then I take a XOR of that because 0 XOR 1 is 1 and 1 XOR 1 is 0 so we have flipped the bits. Will this code correctly flip the bits? Fine. So I've written the code for flip, but for reversal. Because it is only 32-bit integer. We do it before and without answering what will happen. Let me see. Nothing happens. Any other solution that I have? No, it's the same. That was nice. These, you have to remember those tricks. They are helpful. Having weight. 3. You can run a for loop and figure that out. Anything else that you can do? I've started this question also. Yep. Anything else that you can do? We can do some XOR masking or something. Let me think. I'm just able to think about running a for loop, figuring out once, which is easy. Just do an AND of it. Int count while n count plus is equal to n and 1 n left shift 1 turn count. Worked. Didn't work. But there is a better solution than this, I know. You do a not and then you do something. There is a solution. Let me see my solutions. I remember you do n minus 1 n and on n minus 1. How does it work? What the hell? You keep subtracting n is equal to n and n minus 1. keep moving. But isn't it the same complexity? No, it is log 2, log n to the base 2, and my complexity is of n. Wait, this complexity is log n to base 2. This 2, so n is 12, n minus 1 is this. The rightmost bit is set. Number of iterations. The loop runs exactly as many times as there are set bits. Number of set bits. Yeah, it's log n. It's log n to base 2. But for this is also, wait, the one that I just solved. Where is my summation? 1 minute ago. No, this is not my summation. The for loop that I just used. The simple for loop. Not this. Yeah, this. This is also log n. Like say, right? Number of bits. Yes, this approach is log n. Then both the approaches are similar and same optimal. They are similar but not exactly. So here it is log n, but Brian Kernigha's algorithm, this is the name of the algorithm. This is number of set bits. Number of set bits is always less than equal to number of bits. What the hell? Shit. Crazy. Number of set bits is always less than equal to number of bits, and therefore that is better. Oh, it was crazy. But why does it always go to number of set bits? Wait. Where is that approach? All the zeros will be skipped. And it will break down. Shit. Number of set bits. Shit. I will also add a comment here. Number of set bits is the complexity here. Number of set bits is always less than equal to number of bits. This is more optimal. Crazy. Because all the zeros will collapse down once we do this, and we iterate over only set bits. Shit, crazy. This was crazy. This is some like scientist algorithm. The name is very big, so I don't remember. Bergin Cunning algorithm. Single numbers. Next question. Crazy algorithm. We have 3 questions left here. It's 5. I will come live, guys, again and then solve it. Bye.